In mathematical order theory, an order-embedding is a special kind of monotone function, which provides a way to include one partially ordered set into another. Like Galois connections, order-embeddings constitute a notion which is strictly weaker than the concept of an order isomorphism. Both of these weakenings may be understood in terms of category theory. Formal definition. Formally, give on two partially ordered sets and a function f. St is an order-embedding if f is both order-preserving and order-reflecting, i.e., for all x and y in S. One has note that such a function is necessarily injective, since f equals f implies x, y and y x. If an order-embedding between two poses S and T exists, one says that S can be embedded into T. Properties. An order isomorphism can be characterized as a surjective order-embedding. As a consequence, any order-embedding F restricts to an isomorphism between its domain S and its range F, which justifies the term embedding. On the other hand, it might well be that two poses are mutually embeddable into each other without being isomorphic. An example is provided by the set of real numbers and its interval -1, 1. Ordering both sets in the natural way, one clearly finds that -1, 1 can be embedded into the rails. On the other hand, one can define a function e from the real numbers 2, -1, 1, as this is the projection of the real number line to the circle with circumference 4, and embeds the rails in 2, -1, 1. Yet, the two poses are not isomorphic. -1, 1 has both a least and a greatest element, which are not present in the case of the real numbers. This shows that an isomorphism cannot exist. In a retract, the first of the two maps must be an order-embedding. However, not every order-embedding is a contraction. As a trivial example of this phenomenon, the unique order-embedding from the empty poset to a non-empty poset P has no retract, because there is no order-preserving map from P to the empty poset. More illustratively, consider the diamond poset with elements 00, 01, 10, 11, with 00 less than 01 less than 11, 00 less than 10 less than 11, and 01 incomparable to 10. Consider the embedded subposet V, consisting of 00, 01, 10. A retract of the embedding V to diamond would need to send 11 to somewhere in V, above both 01 and 10, but there is no such place. Additional perspectives. Poses can straightforwardly be viewed from many perspectives, and order-embeddings are basic enough that they tend to be visible from everywhere. For example, a poset is a set equipped with a binary relation. An order-embedding A to B is an isomorphism from A to an elementary substructure of B. A poset is a graph. An order-embedding A to B is a graph isomorphism from A to an induced subgraph of B. A poset is a category such that each Hom set has at most one element. An order-embedding A to B is a full and faithful functor from A to B which is injective on objects, or equivalently an isomorphism from A to a full subcategory of B.